record class so that you could hear it all. You guys are, of course, going to talk really loud as well so that the microphone will pick you up. Yeah, I can tell already. All right, so yes, today we have two major parts. We need to do some right triangle trig, which is what you learned in geometry. Did it again last year a little bit in Algebra 2. It's what most people think of as trig. That's what the definition of trig here is. So and then of course we get to go back and do everybody's favorite special angles. And I have these faces that are looking like, what are special angles? You'll remember them, trust me. And if you don't, I'm going to bug you with them so much for the entire rest of this semester that you will have them ingrained in a few weeks. All right, but however, first of all, right triangles. Think back to the days of geometry. You learned a saying for knowing sine, cosine, tangent. We could look at this in terms of stick your rotten crazy xylophone. It would work, but you'll notice these triangles are not on a coordinate system. Now we're just talking about a triangle in the plane. You'll notice I have used alphabetic letters on the sides now, because we are not working on a coordinate system anymore. So when we're talking about a triangle out in the real world, we use angles ABC typically. C is supposed to be your right angle. If you're doing, particularly if you're doing ABC. So you'll notice I have angle C set up here, and side opposite is side C. Sides are little letters, lowercase letters. Angles are always capitals. Okay. You learned a saying, there's actually two of them out there, because I know the students from Bern know a different saying for this, so I'll talk about both of them. Anybody remember anything about Oscar? There we go. You learned Oscar had a heap of apples. Okay, what did the O stand for? The opposite side, and H is the hypotenuse. A is the adjacent side, and of course the hypotenuse, and then we have opposite over adjacent. Okay. You'll notice I don't have cosecant, secant, and cotangent written up here. That's because for these kind of problems, sine, cosine, and tangent will solve everything you could ever want. There is no need for the other three. That's why you didn't learn the other three in geometry, because they are unnecessary. These three will solve everything. You'll notice on your calculator, you have a sine, cosine, and tangent button. Do you have buttons for secant, cosecant, and cotangent? No, you don't. There are ways to get them out of your calculator, but it's kind of annoying. Most of the things you will do with a calculator and trig functions will use these three, the primary three trig functions. So that's why they're there. Okay, the other saying you can use for this that incorporates the S of sine, it is S-O-H, C-A-H, and the T-O-A. Some books teach it this way. If you write that out, you have S-O-H, C-A-H, T-O-A, and they call that SOHCAHTOA. So if you want to remember SOHCAHTOA, that's another way to remember that. It's whichever, probably your brain learned first is the one that's going to like. I don't care. Am I going to ask you to write those three come test times? Yep. So you're going to have to know that. All right. I want to take a look at triangle ABC I have over here on the right with the 8, 15, 17. That is a perfect right triangle, by the way. It's a perfect Pythagorean triple. And if I said to you, okay, what's the sine of angle A out of that particular triangle? You would look at it and go, sine of angle A is, if we come here, sine of angle A is supposed to be the opposite side over the hypotenuse. Okay, so when it talks about opposite, it's opposite of what? The angle. So if you're doing sine of angle A, you have to go, what side is opposite angle A? Well, opposite angle A is 8 over hypotenuse, which is 17. Okay, now, does it make a difference, though, if I had asked you to find the sine of angle B? Would you still get the same answer?
No.
No, because now the opposite side, opposite of angle B, is going to be what? 15 over hypotenuse of 17. So it makes a difference. That's why I go a little ballistic about you having angles with your trig functions. If you don't have that angle there, you don't know which angle you're trying to be opposite of. It's essential that you have an angle with a trig function, always. Okay. Now, there's a pattern here I want y'all to notice. What's the cosine of angle A and the cosine of angle B? And sometimes people have trouble with adjacent. Adjacent to what? Well, once again, it's adjacent to the angle. So if I'm asking you for the cosine of angle A, I want the side that's adjacent to angle A. Okay, well, there's actually two sides that form angle A that are adjacent to angle A. It can't be the hypotenuse, though. So the adjacent always has to be the other side that's not the hypotenuse. So adjacent to angle A in this case is 15 over 17, which means the cosine of angle B is what? 8 over 17. Okay, anybody notice something strange about those answers we just got? Yeah, they're switched around. Sine of angle A and cosine of angle B are the same value. They both got 8 over 17. Cosine of A and sine of B are both the same value. What do we know about the measures of angle A and B? I got it, they equal 90. Do y'all buy that? Do A and B have to add up to be 90 degrees? Yeah, they do. Okay, what do you call angles that add up to be 90 degrees, geometry term? What did you say? Supplementary is 180. Complementary. Angles that add to 90 degrees are complementary. So A and B are complementary angles. Technically then, we can establish, let me look up here, this relationship. We know the sine of angle A is going to equal the cosine of its complementary angle, because sine of angle A was equal to cosine of angle B, so I could write that, I could write angle B as the complement of A by saying it's whatever 90 minus A is. And that's true for any set of angles you do. Now, here's the really cool part. Ever wonder why they named them sine and cosine? Cosine is short for complementary sine. This is sine and complementary sine. So therefore, you have tangent and cotangent would be complementary tangent. And secant and complementary secant. So this little relationship is true between sine and cosine. It's also true between tangent and cotangent. And it's also true between secant and cosecant. So there really is a reason they named them that way. They're all complementary, and have complementary angles. Okay, that little relationship, they shortcut it. It's a relationship. They call them complementary functions, but they'll shorten it up. The instructions in your assignment will say use cofunctions. Cofunctions are complementary functions. So if you see that in instructions, use a cofunction, they mean use the complementary function. Now, here's what they're going to ask you to do. Nothing too horribly significantly difficult. You should be able to handle this. They may say to you, okay, you know the tangent of 20 degrees. They're going to say, write it in terms of its complementary function. So what's the complementary function of tangent? Cotangent. And then what angle would it have to be? Why, she said 70. Where did she get 70? Yeah, 90 minus 20. Take this angle, subtract it from 90. So the tangent of 20 degrees would equal the cotangent of 70 degrees. If I said you have the cosine of 56 degrees, and I say write it in terms of its cofunction or complementary function, what would I do? It'd be the sine of 90 minus 56, which would be 34 degrees. If you punch that in your calculator, if you punch in cosine of 56, hit enter, punch in sine of 34 and hit enter, you will get the exact same numbers. Some iffy decimal, but they'll be the exact same value. So that's just handy information to sometimes know. Sometimes it can bail us out of trouble when we need to know something. Okay. So that's the first little part of your assignment. Will just be naming the trig functions and writing the complementary functions. Have I blown you away so far? You're going to make me wish I had a super soaker. We're not very lively this morning. Oh, I didn't want that. Sorry. Alrighty. We're going to apply our knowledge of our trig functions here. We have Ernie. This is the white thing is a snowdrift. Okay. Ernie is my outdoor dog. Ernie is standing on top of the snowdrift. He loves the snowdrift. He thinks they're great friends. And this is Dinah the dachshund down here on the ground. Ernie is really into his math. Ernie and Dinah are. And we will notice that the measure from straight down below Ernie over to Dinah is 32 feet. Okay, and I want you to figure out if Ernie looks down at Dinah with an angle of depression, that's supposed to be 18 degrees. It won't keep my little degree symbols up there. Wants to know how tall the snowdrift is. Okay, well, do you remember talking about angles of elevation and depression? We did them last year. I know you do them in geometry quite a bit. Okay, an angle of elevation is measuring what? The rise. So when you do an angle of elevation, you are going from a horizontal line upward from that horizontal line. That's an angle of elevation. Okay. When you do an angle of depression is the one I have people miss all the time. Angle depression is going to be from the horizontal line downward. So, alright, our angle of depression. Anytime they say angle of depression, you have to think, where's my horizontal line? And then you go down from your horizontal line. That's really, really, really crucial. Okay, before I get into solving this problem, because I can't do it in 1 minute, we're going to pause a moment, and we will be back.